Okay, Intermediate Algebra 92, Unit 0, Lesson 3, Warmup. All right, compound inequalities and give interval notation. So in my notes I've been doing brackets to help with interval notation, but for this one I want to the graph should be open and closed circles, and the interval notation is the brackets, so I want to be clear on that. So I know the key has brackets, so I'll do the circles here, okay? So x is greater than a negative 3. So let me put some dashes on here. 1, 2, 3, negative 3. 1, 2, 3 is a 3. So negative x is greater than negative 3. So that would be an open circle going this way. X is less than a 3. That'd be an open circle going this way. So when you put them together and you put your final answer in, you want to put it in like that. And that would be a soft bracket on the negative 3 and a soft bracket on the positive 3. Okay, because this is an and you want the overlap area only. I probably don't have that many colors. Oh, I do. Okay. This is the final graph here because it represents the overlap numbers. The numbers, think about it, 0 is greater than a negative 3 and it's also less than a positive 3. So x could be 0. Okay. All right, this is also an and. I call these a triple. Okay, those are also ands. So I personally need to pull them apart to graph them. So this is x is less than 3 and x is greater than negative 3. This order here doesn't matter as long as you're graphing them, both of them. Notice how it's open to the x and pointing to the negative 3. So this has to be open to the x and pointing to the negative 3. Okay, so which actually makes it the same as the last one. So this one's going to be the same when you're graphing and the same for your intervals notation. Okay. All right, 1, 2, 3. This is also a negative 3 and a 1, 2, 3 going on. Let's see, this says less than negative 3 and greater than a 3. And it's an or. Okay, so soft bracket negative infinity negative 3 union, because it has to be in, it could, the x, the solution, what x equals could be in this half over here or in this half up here. So either one. Okay, if you have a negative 3 and a negative 1 and it is greater than a negative 3 and greater than a negative 1, greater than a negative 3 and greater than a negative 1, they're going this way. So that looks like it's wrong on the key. I need to fix that. So x then, let me check. So x then is greater than a negative 3. X is greater than a negative 1. And this is an and. So the overlap area is kind of from here to here, right? Infinity. So we want to use the smaller. So this would be a soft bracket on negative 1 and a positive infinity going that way. Yeah, I got that. Yeah, I think the key's wrong on that. Okay, this one here, 1, 2, 3, 1, 2, 3. And this says less than or equal to negative 3. This one says greater than a 3, and it's an and. And notice how they do not meet, so there isn't an overlap area. Okay, there's no way a number can be in here and in here. It just can't happen. So this one would be no solution. And in the homework, you just want to leave a blank graph. You don't want to put any of this here. Okay. If it's negative 3, 1, 2, 3, and or 1, 2, oops, negative 1 would be here. Let's see if I can, so greater than or equal to a negative 3, right? And then less than or equal to negative 1, and it's an or, which means it goes this way and this way because these two overlap and it's or. This is all real solutions. Okay. And the bottom of the page here, let's see, the absolute value, just a little practice. The absolute value, think about absolute values. If I had another number line here and you had a positive 5 here and a negative 5 here, there are 5 units. Oops, hold on. Negative 5. Sorry, negative 5. Okay, I think it's the wording. Sorry for writing in the here. Let me write it down here and then I'll put it over here. If I had a negative 5 and a 0 here. Okay. The absolute value of a negative 5, how far is it from here to here? The distance from 0 is 5 units. Okay. So the absolute value of negative 5 is 5. The absolute value of negative 5 is 5. The absolute value of 5 is also 5 because it's 5 away. Because it's 5 away, it's a distance, so therefore it's always positive. Absolute values are always positive. So the absolute value of a positive 5 is also a positive 5. Okay. If x is 5, the absolute value of x is 5, then x is a negative 5 or a 5. So when we solve absolute values, we need to know that this x could be two different things. That's why it's going to be split to be solved. Okay. Could the absolute value of x equal a negative? No, it cannot, because remember, absolute values represent a positive number. Okay, it's because it's a distance. All right, so that's how I remember it anyway. If you're solving just like you would with an absolute value in here to get the absolute value alone on one side. So the absolute value of what's in there is a 3 or a negative 3. Okay. The absolute value equals 5. So we don't know what x is going to be and we're trying to solve it. The absolute value is already alone on one side, but the x could be two different things. So, so it might be best to take off the absolute value bars and write it like this. And then over here, you're going to figure out what the other one is by putting a negative 5 over there. Okay, so this is going to be 8, x equals 13, and 8. So x is going to equal 3. So the solution is 13 or 3 would work in there. Think about it. If this is, if this is 13 minus 8, the absolute value of 13 minus 8 is a positive 5, so that works. Okay, even if you put in a 3 minus 8, absolute value of 3 minus 8 is 5. This is going to be negative 5. That also equals 5. That also works. Okay. This one, I need the absolute value alone on one side. That's going to be a negative 3. And since it's an absolute value, I didn't take off the absolute value bars, I just reduced away the 3. So the absolute value is alone on one side. Can it equal a negative number of any kind? No, it can't. Okay.